I said, this is going to be the first of two parts. So today we're going to look at a few examples. And so if you look up here on the board, it says solve 4 sine x equals 2 sine x plus root 2. So your first goal is going to be to isolate the trig function. Okay? So in order to isolate the trig function, what do we need to do? What?
Squares.
You see there's two of them, right?
So you just minus 2
There,
sine x?
yeah. There's a sine x and a sine x, so we need to combine them. So the easy way to combine them is just subtract 2 sine x from both sides. So if I take 4 sine x and I minus 2 sine x, what am I left with? 2 sine x. And that's going to equal what number? Root 2. So now, if you remember what I said, we need to isolate the trig function. So I need to get it all by itself. So what do you need to do now? Divide by 2. Good. So here I get sine x to equal root 2 over 2. And so this is where your blue sheet comes in really handy. Because you're going to go to the sine column, and you're going to look down the sine column, and you're going to find out what values does sine equal root 2 over 2. I want to know the values in terms of pi. Pi over 4, and what else? There should be another one. 3 pi over 4. And there you go. That's it.
That's it.
See how nice that blue sheet is? Okay, it's going to come in really, really handy on your homework.
Do you have an extra blue sheet?
On the internet, you can copy off a blank one. I've got one on the website. All right, so here you go. 5 cosine x equals 3 cosine x plus root 3. Whole goal is to isolate the trig function. So what are you going to do?
Minus 3.
Yep, minus 3 cosine x from both sides. So on the left side, what do you get?
2 cosine x equals
Equals root 3. Yep. And then, so now to solve, what am I going to do? Divide by 2.
2.
So I have cosine x equals root 3 over 2. So on your blue sheets, you need to go to the cosine column. You need to locate where does root 3 over 2 occur. And where else? There you go.
These problems are good. I understand.
Okay. You like these better than the identities?
Yes.
Just wait, there's more.
No, that's pretty much it. We're going to be solving equations. So we're going to be looking at different types of equations. And if you notice, this one's a little different, but you can still solve it. So what do you think you need to do first?
Minus 1.
Minus 1. Very good. So I'm going to subtract 1 from both sides, and I get 4 sine squared x equals 3. What am I going to do now? Divide by 4. Perfect. So I get sine squared x equals 3/4. Yep, and take the square root. Now, remember, whenever we take the square root of something, we have to take both the positive and negative. Okay, so it holds true also with the trig functions. So I have the sine of x equals plus or minus. Now I'm going to break this up. On the top, I've got root 3. On the bottom, you have root 4. But what do you know the square root of 4 is? 2. So once again, you go to your sine column. I'm looking for anywhere where sine is plus or minus root 3 over 2. So what do we have? Pi over 3? 2 pi over 3? 4 pi over 3? How about 5 pi over 3? You should have a total of 4 of them. There will be 2 positives and 2 negatives. Okay, the 2 positives will be at pi over 3 and 2 pi over 3, and the 2 negative ones will be at 4 pi over 3 and 5 pi over 3. So far, so good? Okay, we're going to look at 2 more. This is the first one. Alrighty, so some of you might think you're going to divide by cosine x. You can't do that because the minute you divide by cosine x, you actually eliminate a cosine from the left side. So that is not the way that you're going to solve this. What we're going to do instead is we're going to subtract 3 cosine x from both sides. So you can only divide if you do not get rid of a trig function. In this case, we do. So on the left side, I have cosine x times sine x minus 3 cosine x. And that's going to equal 0. Okay. So now I've got 2 terms. What do you notice about each of those terms? They each have a cosine, right? And so when we did the verifying identities and the proving identities, if they each had something, like in this case, they each have a cosine, what would we do? Wouldn't we take it out? That's right. We're gonna factor it out. We're gonna take out that cosine. So when I take cosine from cosine times sine, what does that leave me with? Sine x, and then what? Minus 3. So now this is one of those instances of where you have the zero product property. We learned about factoring last year. The zero product property states that if you have 2 terms, you set each of the terms equal to 0. Okay, so in this case I'm going to set cosine equal to 0, and then I'm going to set sine x minus 3 equal to 0. Okay. So first of all, where does cosine equal 0? Pi over 2 and 3 pi over 2. So there's 2 solutions. Now I need to solve this for sine. So what does sine x equal? 3. And so where on your chart does sine equal 3? It can't because it is greater than 1. Okay, so really you have no solutions from this side. Now you don't put a no solution here because I already have 2 solutions in green. Okay, so there's nothing from here. Okay, so that one's done. All right, so far so good? We got one more to go. And this is the last one today, and I'll let you work on your homework. What? 2 both sides? Oh, okay. Okay, on this one, if you notice, this is actually in a quadratic form. Okay, a quadratic form. And so if I were to look at this, this is really the problem I have. And so I'm going to try to factor that. And so in order to factor that, I'm going to look at the last term. Okay. And the last term I get is a 2. And so I have to think to myself, okay, I'm looking for 2 factors of 2 that differ by what number? 1, because that's the number out here in front. So what are the 2 factors of 2 that differ by 1? 2 and 1. How do you get a positive 1 from 2 and 1?
Negative 1 plus 2.
Negative 1 plus 2. Good. So now the question is, what do you put first? Okay, so now normally you're used to problems like this, or at least this is the ones you're thinking of. And if I would factor that, I would do x plus 2 times x minus 1, right? And I would do whatever this middle term is. That would be what goes here. Well, I'm going to do the same thing here. This middle term is cosine squared, right? So that's what I'm going to put here, and that's what I'm going to put here. And this is the thing, if you take cosine squared times cosine squared, that gives you cosine to the 4th. That's exactly what you wanted. Okay? So now, zero product property. Zero product property states that either cosine squared x plus 2 equals 0, or cosine squared x minus 1 equals 0. So you've got 2 sets of problems here. What do you do to solve this one over here? So I minus 2, so I get negative 2. What do you do now? Square root, important thing to remember again is the plus or minus. So on the left I get cosine x. On the right, I get plus or minus.
Oh, 2i.
2i, root 2i. So do you have an instance of where we're having root 2i with cosine? No. So that one's done. Let's look at the next one. Okay, because you can't have I. So here I get cosine squared equals what? 1. Square root, square root. So I get cosine x to equal plus or minus 1. So tell me where that occurs. 0 pi and 2 pi. Now this is the thing. In this case, the answer is actually going to be just 0 and pi. You aren't going to have 2 pi. All right, questions? So far, so good? Okay, here's where I want you to get started. Now, let's go ahead and look in your book and make sure that we understand what we're doing. Okay, so page 331, 1 through 18. Now, what it tells you on 1 through 12, okay, it says solve each equation for all values of x. I don't want you to do that. I want you to basically solve just like we did in class. And so really, that is the second set of instructions. Okay, when it says find all solutions of each equation on 0 to 2 pi, that's what you're doing 1 through 18. Okay, so if you check your answer with the back on 1, 3, 5, 7, 9, 11, it's probably not going to match. Okay? They're going to have something that'll be like plus or minus 2n pi with every one. I just want you to find the solutions between 0 and 2 pi. Okay. Questions? Alrighty. So Tuesday, we're going to be finished up the rest of that section.